All right, so this is your review for activities 10 and 11. Just a quick reminder here at the beginning that there will be two parts to the mini quiz for activities 10 and 11. There will pretty much be two parts to every quiz or test in Algebra 2 from this point on. So on this particular mini quiz, everything from activity 10 is going to be on the graphing calculator part. Everything from activity 11 is going to be on the non-graphing calculator part. Again, if you wish to bring a scientific calculator to use on the non-graphing calculator part, you may, but you may not use phone, iPod, or a graphing calculator on that section of the mini quiz. So, let's take a look at what's in activity 10 first. So that is the calculator part. So I'm just going to do a couple of these together. So first, we have 13 through 15, which are all the same type. This is from lesson 10-2. Write the equation of the quadratic function whose graph passes through each set of points. So the steps for this, remember, are to... So we'll just do number 13. Step 1, you need to enter the x coordinates in one list in your graphing calculator. Then you need to enter the y coordinates in a different list. Remember that for this, you need to make sure that they match. So you have to make sure that the x coordinate is across from its corresponding y coordinate. Then we are going to run quadratic regression. So I'm going to bring up my on-screen graphing calculator here. All right, so in order to do what the directions ask me to, which is to write the equation, I need to enter the data that they gave me into my list. So entering data, I generally press Stat, and then I choose choice 1, which is Edit. Now, you can see that I've got pretty much all of my lists full here, so that means I need to delete some. You can delete them manually. However, it is better and easier to delete them all together. So I've got stuff in lists 1 through 5. So if I go back and I do Stat, choice 4 for clear list, and I tell it list 1. It's not letting me press the 1 here. Sorry, move this for a second. 1, comma, and then list 2, so second 2, comma, second 3, that gives me L3, comma, second 4, comma, second 5. So I'm telling it to clear all of these lists, and then I press enter. It tells me done. Now when I go to Stat Edit, I should be able to see clear lists. Beautiful. So the x coordinates of the point on number 13, I have -3, so enter. Then -2, enter for the second x coordinate, and then 2, enter. So then I go to the y coordinates. In list 2, the corresponding y coordinate with -3 was 0. With -2, it was -3. And then 2 had 5. So I've got all 3 of my points exactly how they appear here in the list. So -3, 0, -2, -3, 2, 5. So now, once I have the data entered, I run a quadratic regression. I go to Stat. I choose Calc menu, so scroll right. I choose choice 5 for quadratic regression. And then I need to tell it what lists. Right now mine says list 4, list 5. I need it to say list 1 and list 2 because that's where I put the data. So press second 1 to get it to say L1, then second 2 to get it to say L2. Now, remember, normally we would have it store the regression equation here by doing vars, y vars, choice 1 for function, and then choosing a place. Now, here you could skip that step because it doesn't ask you any other questions. It just asks you for the equation, but it doesn't hurt. And what I had suggested was just practice doing this every time because then you won't forget to when you need to. So then press calculate, and then it tells me, here's the format of my answer. Here are the values that I plug in for A, B, and C. So your answer for 13, y equals, we don't write 1x squared, we just write x squared. So y equals x squared. Then b is 2, so plus 2x. And then c is negative 3, so it'll be a minus 3. And that's it for those. So for 13 through 15, that's what you should be doing. So next, I want to look at when you have to answer a question about data that you have entered. So we're going to look at the data that is given to you in 23 through 25, so this data table here. So because the speed distance is the same for both the car and the truck, you only have to use 3 lists here. So I can use list 1 for the speed data, list 2 for the car stopping distance, and list 3 for the truck stopping distance. So if you haven't already entered that data and you needed help with these particular questions, 23 through 25, then you need to take a minute here, pause the recording, and enter this data because you need this on your graphing calculator. So here's what your list should look like after you've entered all of that data. So number 23 just asks you to perform quadratic regression on the data for each vehicle. So that's the same thing that we just went through in the last problem. You go to Stat, scroll to Calc, choose quadratic regression. So for the car data, you're doing list 1, list 2, and you're doing pasting into the store regression equation. So vars, y vars, function, and then paste in y1. Now, when you go to do the second one, so this is how I got the answer for the car that's on your answer sheet there in 23, because these are the values that you would get when you plug those in. So when you do that, for the truck data, the second set of data, you have to make sure that you are telling the calculator the right thing. When you go to Stat and Calc and Quadratic Regression for the truck, don't just press list 2, list 1, list 2, y1. That's not where that data for the truck is. The X list is L1, but for the truck, the Y list is L3. So you have to tell the calculator that. Also, you don't want to store the regression equation in your y1. That would take away the equation for the car. You need to store this one in y2. Apparently on some of the newer calculators, there's a shortcut to get to the vars, y vars function that I actually didn't know about because my personal calculator is older. But I guess if you press alpha trace, it actually automatically gives you this choice. Now that's only on the really new calculators. So if you press alpha trace and it doesn't give you this, that just means you don't have that shortcut. So you can choose choice 2 then directly there to find, to paste that regression equation. So when I press calculate, that's how I got the second part of my answer for the truck data on 23. So now I need to talk about how you answer, say, number 24. It asks, use your models, that means these equations, to predict how much further it would take the truck to stop from a speed of 50 miles per hour than it would the car. So speed is your X data. So it's saying when X is 50, how much further is it going to take the truck to stop than the car? So if I'm trying to answer this question, I need to look at the graphs. So I need to adjust my plots. So I'm going to be using plot 1 and plot 2, so I'm going to turn them both on. Then I need to make sure they've got the right lists. So I'm going to go to second stat plot. Right now they don't, so I am going to here change the lists in plot 1 to match. My X list is L1. My Y list is L2. So that one's changed, so that's good news. Then I'm going to go over to plot 2. It's on, but its X list says L2 and L3. We want it to say L1 and L3 because the X data was in L1. So now I'm good on that. I've got the correct functions, so I can graph it. Again, if I press Zoom Choice 9, it will kind of give me at least a starting point for a window. You can see, obviously, I'm missing a lot. I need more on the left side and more on the right side. So when I go to adjust my window, left is X minimum, so I need to make this lower. So let's say that I change that to say -5. And I change my X max. I need that to be bigger, so let's say I make it 55. X scale, that's just what you're counting by, so let's count by 5s maybe. Y min, I'm going to change to -5. I couldn't tell if I needed more Y max or not, so I'll probably leave that for now and just see what it looks like. All right, so I still can't see the whole parabola, but because I've gone into the negatives and this is a real life situation, I probably don't really need to keep adjusting because I know that negative values don't make any sense for this situation. So what I see here is going to be good enough in order to do this. Now, to answer number 24, for an X value of 50, what you should do, because you don't want to scroll down in the table to 50, and again, if I give you a value that is not an integer, you won't be able to use the table. So we had gone through in lesson 10.3 how to use second trace. You need to know how to use value and 0. If you need to go through all those steps again, remember there's a video for lesson 10.3, a whole separate video linked on the website that you can watch if you need more help with that. But I'm just going to quickly go through this time since it should be review. I choose value and I type in 50. I press enter. It tells me. Now, it's saying the blue. Blue was my car data. So that means it's going to take that car about 228.4 feet to stop. So if I go back here, and this is number 24, I'm just going to record because this is kind of like work, 228.4 feet. Because this is something I could give you partial credit for if you have this written down. So then, remember to switch to the other equation. You just press down. So now it goes to my red, my Y2, which is the truck data. You can see the Y value when X is 50 here is 269.5. So the truck, 269.5 feet. The question asks, predict how much further it would take the truck to stop than the car. So all you're going to do is subtract these two values. So it's approximately, when you subtract those, 41.1, depending on what you rounded to, feet is your answer. Again, if you need more help with finding an x-intercept, which you didn't have to do on the review problems, but we did do in the lesson and the homework, make sure you check out the 10.3 video. It's at the very end to do a review of the second trace 0 function. All right, so that covers activity 10. So that's everything from the graphing calculator part. So now we're going to move on to activity 11, which is on the non-graphing calculator part. So everything here we should be doing by hand. So First thing we want to do, we're just going to look at one of the pretty straightforward ones. So we're going to look at oops, wrong screen here. Number 3 on page 189 gives you g of x equals x plus 2 squared plus 3. It asks you to describe the transformations and then to graph it. So this plus 2 on the inside, remember, means horizontal shift left 2. Then this plus 3 means that there is a vertical shift up 3. So when I go to graph that, vertical and horizontal shifts mean I'm moving from my vertex of the parent function to get the vertex of my new function. So left 2 up 3, left 2 up 3. Here is where my vertex is for number 3. After that, remember, it's just parent pattern. So parent pattern here. From this vertex, I'm going to go left and right 1, up 1. So left 1, up 1, and right 1, up 1. Then I'm going to go left and right 2 and up 4. So right 2, up 4, 1, 2, 3, 4. And then from the vertex left 2, up 4. And then connect the dots. So there is your answer for the graph and the transformations. Again, please make sure you're answering all parts of the question. Next one I want to talk about is number 7, because it asks you to identify the vertex and the axis of symmetry. So number 7, the equation was g of x equals x minus 8 squared. So there's only one transformation here, and even though they didn't ask you for it, it's probably good for you to know that this is a horizontal shift, right 8, because that tells you where the vertex is going to be. If I go right 8 units, that tells me, oh, my vertex is right here, which is the point 8, 0. Axis of symmetry, remember, is the line. It's a vertical line that goes through the vertex. So it's always x equals, because all vertical lines are x equals, and then whatever the x coordinate of the vertex is, which in this case is 8. So there's your answer there. Now we're going to look at one where we have some shrink stretches and reflections. So we're going to look at number 18. So we've got g of x equals negative 3, x plus 2 squared minus 5. All right, so in order to perform the graph, you have to know the transformation. So we're going to list those first. The order that you list them is not important. I usually list them in the order that I graph them, but it doesn't really matter. So I might do horizontal shift left 2. That's this. Then vertical shift down 5. That's this. So I've taken care of these. Then I need the negative. That means that there's a reflection in the x-axis. And then my 3, that's outside. Outside things are vertical changes. That is a vertical stretch by factor 3. Remember that when you are listing transformations, you have to list all parts of it. You can't just put vertical stretch. You need to say the factor. You can't just put reflection. What kind of reflection? It's a reflection in the x-axis. Don't just write left 2. You have to say horizontal shift, or you could say horizontal translation. That's the same thing. So these right here are your transformations. So when I go to graph it, let me draw myself a graph here first. Okay, so when we graph, we always do the shifting first because that's the location of the vertex. So we do that first, left 2, down 5, left 2, down 5. Here's my vertex. Next, I determine which way it opens by whether there's a reflection or not. There is a reflection. So that means when I go to list my parent pattern, instead of writing up, I'm going to write down. So I know that I'm going to need 5 points, unless they won't fit in a standard coordinate plane. So when I go to list my parent pattern, 1, 1, 2, 4 are where I generally start. Sometimes we list more if we need them. So reflection told me it's going to be down here. So I'm ready now for my vertical stretch by a factor of 3. Remember, the type tells you whether it's the left side or the down side that is changing. Vertical is up and down, so we're going to be multiplying on this column by a factor of 3. So times 3, which equals 3, times 3, which equals 12. So that means that I'm going to go from my vertex, left and right 1, down 3. So right 1, down 3, 1, 2, 3. Then I'm going to go left 1 and down 3. Now, typically we would also go left 2, down 12. If this vertex had been up higher, we would have room for that. But here I don't have room to go down 12 in a standard 10 by 10 coordinate plane. So remember, in those cases, and only those cases, it's okay to only plot 3. So connect the dots that I have, remembering to make sure your parabola vertex is rounded, and that is what your graph should look like. All right. Next one that I want to go over is one where they give you the picture and you have to write the equation from that. So we're going to look at number 23 next. So here's the graph. It says describe the transformation, then write the equation of the transformed function. So when I describe the transformations, I look at the vertex first. So as I am looking at this, I see that my vertex is at the origin. It's at 0, 0. So that means the vertex is the same as the parent function. So that tells me I do not have any vertical or horizontal shifts. So after I look for vertical and horizontal shifts through the vertex, then I look to see what direction it opens. If it opens up, there is no reflection. If it opens down, there is. This opens down, so that means for the first transformation that I'm writing here on number 23, I write reflection in the x-axis because it opens down. Next thing I need to look for are what are the other points. They won't always be labeled, but they will have dots on them. And remember, this is our matching game. You match with the parent pattern. So if I look at my parent pattern, oops, that looks kind of sloppy, sorry. Typically, we have left and right. In this case, it's down because of the reflection. But we have 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, so on and so forth. If you look here and you're trying to match, there is nothing in the parent pattern that has a y value of 3. So I can't match that one. I can, however, match left and right values of 1 or -1. So left and right 1, down 1 is what I'm matching. I'm matching this point. So I'm saying typically I would be going left and right 1, down 1. This is the parent. Gosh, my handwriting's so sloppy. There we go. That's the parent. What I actually see when I look here is left and right 1, down 3. So, again, all I'm trying to figure out is what did I multiply by here? It's the y coordinate that is changed, so you know that it's a vertical change. So you just ask yourself, what did I multiply 1 by to get 3? So 1 times what equals 3? Obviously, the answer there is 3. So that means that this is a vertical stretch by a factor of 3. So you're never going to have a vertical stretch and a horizontal stretch or shrink in the same problem. So once I've done that, I'm done with my transformations. So now I need to write its equation. So remember, our equation is in the general form a times b times x minus h squared plus k. So reflection controls my a value. It controls that it's negative. Vertical stretch is also controlled by a. So that means this is telling me a is going to be negative and it's going to be 3. So I write my function. In this case, let's see. It tells me that the name of the function is g of x in the picture. So we write g of x equals negative 3x squared. I don't write b's, h's, or k's because these were the only transformations, which means I'm not using any of those other letters. So there is that. All right, very last thing that we need to talk about is how to write something in vertex form, in a quadratic in vertex form, when we are given a standard form. So we are going to look at number 29. So it starts out f of x equals x squared minus 16x plus 71. So I take the f of x out and I move my constant to the other side. So f of x out, then move my constant with opposite operations. And then remember that we want to flip-flop the sides. So x squared minus 16x equals negative 71. Again, we had said in class, if you can just look at this and automatically go to here, that's fine. You don't have to show this. If you keep missing it, then you should show it. So here's where now I'm going to go from. So once it's in this form, now I need to factor out the a value. Here the a value is 1. So 1 times x squared minus 16x equals negative 71. Then I'm going to add blanks. We fill in the blanks by doing b divided by 2 squared. B is negative 16, divided by 2 is negative 8, squared is 64. So 64 goes in the left side blank, right side blank, I multiply times the a, which also is 64 in this case. So then left side, my a is 1. I need to factor this as a PST. So I know it's a single parenthesis squared. Square root of x squared is x. Sign in the middle is a minus. Square root of 64 is 8. So I'm done. Right side, combine the like terms, which in this case gives me negative 7. Now, I'm not solving. Don't try to solve. I'm writing the equation in vertex form. So because this is a 1, I don't really need it anymore. I need to have f of x equals, I've got x minus 8 squared, because again, I'm trying to get it to look like this. You have to have your k value on the same side, so I now need to move this back over by adding it. So plus 7. And that is how we got that answer. Again, it wants you to identify the vertex, so this is transformation looking. This vertex is x coordinate of 8, y coordinate of 7, because this would be horizontal shift right 8 and a vertical shift up 7. So this is the location of the vertex. The axis of symmetry is x equals the x coordinate of the vertex. And it said to tell which direction it opens. So because this does not have a reflection, that means that it opens up because this is positive. All right. Last thing that I want to remind you of, I'm not going to do all of 33. I'm just going to briefly touch on part A. When you are writing the standard form for this one, again, you have to complete the square. So all those steps that we just did here, we need to do here as well. So I take out my h of t. I move this to the other side, so I end up with this. Then you need to factor out that negative 16. It doesn't come out evenly. That's okay. Write it as a fraction. Your calculator can help you with that. I would never give you a complicated fraction on a non-graphing calculator part. So if you were to see something like this, it would be on a calculator part. So this is my next step. When I go to add the blanks, I'm also going to reduce this because those are both divisible by 2. You don't want to work with an unsimplified fraction. So, divide by 2 and square. Dividing by 2, negative 11/8 divided by 2 is negative 11 over 16. When you square it, that gives you 121 over 256. Now, I believe this is a real life situation. I could double check it here on 33. Yes, it is. So here it would be okay to use the decimals if you wanted to because it's real life. I didn't just because it's easier for me to do fractions in my head, which is what I did here. So then use your calculator to multiply these two together, which would give you the blank over here, which is going to give you negative 121 over 16. So again, you can finish this factoring the left. Again, you can use the decimals if you want, but I wanted to get you started on that. All right, happy studying. Make sure you've got all your problems done, and good luck.